video, we're going to take a quick look at how to graph a quadratic function by hand. So I have this quadratic function here, y equals x squared plus 2x minus 1, and I know that's quadratic because it has this highest power of 2. So I know this is going to graph as the U-shaped graph called a parabola, and I just don't know exactly where it's going to be. So one thing you can do when you're graphing really any function, and if you don't know what it looks like, is to make an xy chart. So I want to start by making an xy chart. So let's just throw some x values in there, -2, -1, 0, 1, 2. We'll figure out how y changes depending on what x is. So I'm going to go ahead and go to a calculator here, and we're going to figure out what y is whenever x is changing to these values. So one tip here is whenever you're substituting in for x squared, make sure you put whatever that number is in parentheses. So because I'm substituting -2, I'm going to put -2 in parentheses squared plus 2 times -2 minus 1. So when x was -2, I have an output, a y value of -1. Let's see what happens when we take -1. So -1 in parentheses squared plus 2 times -1 minus 1. And I have a y value of -2. When x is 0, we have 0 squared plus 2 times 0 minus 1, and we have -1. When x is 1, we have 1 squared plus 2 times 1 minus 1, and we have y value of 2. And when x is 2, we have 2 squared plus 2 times 2 minus 1, and we have 7. So I have my xy chart, and I'm going to go ahead and just plot those points. So at -2, I'm down at -1. At -1, I'm down at -2. At 0, I'm down at -1. At 1, I'm up at 2. And at 2, I'm over at 7. 1, 2, 3, 4, 5, 6, 7. Kind of way up there. So we have this kind of U-shaped pattern going on here. And so I know that my parabola is going to look like this. Just kind of follow those points, follow what that pattern is doing, and there's my parabola. Now that's a good way to just kind of get started and see what a function will look like. But it takes a lot of guessing, and if I didn't happen to get the vertex in there, or if I chose some numbers that were over here, I wouldn't have really gotten the pattern. So I want to take a look at a different way to graph a quadratic function using some of these important parts. In the last video, we were learning about the different parts of a parabola, like the vertex, the y-intercept, the roots, the axis of symmetry. And the way I want to learn to graph these is by finding some of these important parts on the graph. So I want to take a look at that same function that we were just graphing before, y equals x squared plus 2x minus 1. Get my xy axis over here. And the first thing that we're going to be able to do is find the feature known as the axis of symmetry. So we need to know a formula here, axis of symmetry. And now we'll have the formula x equals -b over 2a. So whatever b is, it's -b over 2 times whatever a is. So that's what I want to do first. I want to find that axis of symmetry. So x equals -b over 2a. Well, in this case, b is 2, so I'm going to have -2 over 2 times a. Well, there's not anything in front of x squared, so it's implied that there's a 1 there. So 2 times 1. So I have -2 over 2, and so my axis of symmetry, I'm going to abbreviate that AOS, is equal to x equals -1. So what I know about that is an imaginary line that is going to cut that parabola in half. So I'm going to go ahead and graph that first. Wherever this parabola is, it is centered around this imaginary dotted line. And we make that line dotted so that you know that that's not really part of the function itself. It's just kind of a feature of it that's working in the background. Next thing I want to do is find out where that vertex is. So looking back at this, the vertex is on the axis of symmetry somewhere. So if I substitute the value of -1 in for x, what I'm going to find is the y value of the vertex. The vertex is an xy ordered pair. I know that the x value is -1 because it has to be on that line somewhere. And I want to figure out what the y value is. So I'm going to go ahead and take my calculator out. I'm going to substitute negative 1 squared plus 2 times negative 1 minus 1. And I'm going to get my y value of the vertex, which is negative 2. So my vertex will be located at negative 1, negative 2. So I'm going to go ahead and plot that. The next thing I want to find is the y-intercept. I know that this graph is going to cross the y-intercept, or cross the y-axis somewhere. And I want to figure out exactly where that is. Well, fortunately, that is something that is right in our equation. Whatever c is, that is your y-intercept. So our c is minus 1. That means our y-intercept is 0, negative 1. It's going to cross the y-axis at negative 1. So I'm going to go ahead and plot that point. Next thing I want to do is, knowing that this axis of symmetry acts like a mirror, since I have a point that is 1 unit to the right of that axis of symmetry, I know that I also have one that's 1 unit to the left. I kind of sometimes call that the symmetric point. It's really just taking a point on the graph and reflecting it over. Now I have 3 points, so I know that I am going to have a graph that looks like this. If you want to be a little more precise, you can take another x value, like let's say x equals 1. Let's figure out what the y value is at 1. So we have 1 squared plus 2 times 1 minus 1. And at x equals 1, y is 2. Which means that since I know this is 2 units to the right of the axis of symmetry, I have another point that's 2 units to the left. Make sure the only thing you're reflecting over is that axis of symmetry. Now I've got a nice pattern of what my parabola is going to look like, so I'm just going to go ahead and sketch the curve all the way through there. So this is going to be a little bit more efficient than using an XY chart, because it doesn't have to, you don't have to just pick the right values by chance. You can just find the important parts of that parabola and graph them right away. First thing we did was find the axis of symmetry, x equals negative b over 2a. That gave us an x value. Since the vertex is on that axis of symmetry, I substituted that x value and found a y of negative 2, and that's where my vertex is. Then using the c from our function, negative 1, I know that that's the y-intercept, plotted that, reflected it over the axis of symmetry. Just to get more points, I picked an x value to get a y, reflected that over, and we got this nice parabola.